Hi, everyone. Welcome to this webinar from Inside AI/ML, where we are going to talk about building effective data visualization for business intelligence platforms, which are mostly driven towards the right data analysis, getting amazing insights from your data, and facilitating the decision-making process with the right facts and figures. Right. Throughout this entire webinar, I'd like to keep it very interactive. So if anyone has any questions, post it on the YouTube live chat. I will make sure that I keep monitoring it and will answer any question. And I will try to answer any questions that I find on the YouTube live chat. Right. So hi, Nisha. Hi, Mihir. I see your text already. So if you guys have any questions, feel free to let me know. Okay. Let's start with the session. Today's session is going to be pretty interesting because we're going to explore a lot of content, detail, understanding, experience that I have, and I want to share with all of you about how the visualization and data analysis actually kind of synergizes together to give you the ultimate analysis platform and skill set, right? So we are going to explore options for using a range of charts, diagrams, other visualizations. We are going to use these to explain the kind of analysis you can do from each charts and the strategy that you should be using. We are also going to see what kind of colors should we use effectively to represent charts that do not kind of scratch the eye, something that does not look very presentable or professional. I mean, let's not use very dark colors or very bright colors. We're going to talk about that. That's very interesting. Not a lot of videos or webinars talk about that. That's still very important because if the chart does not look right, no matter how much good information it has, it's not going to bring a lot of value to the customers. We're also going to talk about the best charts for detailing cost and ROI and the tricks that you need to know when using responsive visualizations. Okay, so let's start. Charts, diagrams, and other visualizations. So what you can see on the right are a lot of different kinds of charts. Okay, the idea is whenever you look at a new data set, that data set has different data types. It has different, I would say, sizes. It has categorical numerical data. It has missing, non-missing data. It has floats, integers, etc., etc. While considering all of this data and while we are aiming to visualize this data, what we need to make sure is we choose an appropriate chart that gives the insight or the analysis that we want to convey to the viewer of the visualization of the chart, right? So that is why we need to actually distribute our entire requirement into 4 different and unique analysis components, okay? To build a relevant, very clearly communicative and insightful chart, we need to define the analysis type. What is it that you want to analyze in this particular chart? I hope that makes sense. Just give a quick shout out, yes or no, guys, on the YouTube live chat so we can proceed. And also, if you have any questions, please do post the same. Okay. The 4 different analysis types are comparison, where I want to compare one data set with another data set. It can be one column with another column, one row with another row, one distribution with another distribution, right? An example could be sales of the state Maharashtra versus West Bengal, right? Here, I'm trying to compare the sales that have happened in the state of Maharashtra and in the state of West Bengal. And then I should be using a bar chart. Now, whenever we look at a bar chart, you guys might be thinking bar chart is one-dimensional, Pranjal. How are you comparing the sales, right? So let me quickly open my notes and share some ideas with you. Okay, I'll quickly take a pen so I can annotate. Suppose this is the chart that I want to create. The idea is my bar chart can actually be comparison of a single month. For example, this is the sale of Maharashtra, and let's say this is the sale of West Bengal. What this is the comparison for one time period. So what I will have here is, let's see, 2022 quarter one, right? This is one comparison, right? So this bar chart, although is one dimensional, it's for one time period only. Now, if I want to do the same analysis for multiple quarters, right? If I want to do the same analysis for multiple quarters, then I can add more here, right? And this leads to something called as a multiple bar chart, right? This multiple bar chart is going to help me understand the trend in different time periods of the sales comparison of Maharashtra and West Bengal, right? So that's how we start looking at our analysis. Whenever you get a data set, your mindset should be, let me visualize what kind of chart and what is the orientation of the chart that will help me do the comparison between one particular category and another category. And obviously, I can compare 5 categories at the same time or 10 categories at the same time. As long as my entire analysis makes sense, is very precise and accurate, it's good to go. But if I compare 100 categories at the same time, I will honestly be not able to compare categories, all the 100 together. I'll usually be comparing only 2 or 3 categories, which does not make sense. Okay. Just like a bar chart, there are also line charts. What do line charts do? Let's quickly take a pen and get started. Right? Line charts are basically just representing points. So previously, what did we see? We saw that this is a bar chart. Okay. And then we saw this is another bar chart. Let's undo. And this is another bar chart. The height of the bar represents the actual data point. So what I can really do is I can convert this point, this height, into a single point. I can convert this into a single point, and I can also convert this into a single point. And then what I can actually do is I can just remove these. They no longer make sense to me, right? I can just remove these two, and these become my 2 points on the surface. Now I can have multiple points like this for the red, which are going to give me the trend of the red, right? Multiple heights of bars across different time periods. And similarly, I will have multiple points across blue, right? So across different quarters of time period, what was the value of blue and what was the value of red? And then later, I am going to connect these with straight lines. We'll change the color. I'm going to connect this, then this, then this, then this, then this. So I will be able to see a trend of increase, decrease, constant, or whatever between the two values. And this is my line chart for comparison. I hope that makes sense, everyone. I hope that is absolutely clear to all of you. If there are any questions, do let me know. Similarly, there is column chart, right? So comparison is a very, very interesting use case. And in a lot of cases, comparison is what the analysts are looking at in most of the cases. The second analysis type is distribution. Okay. Distribution basically tells us the pattern in data. Let me give you a very interesting example with a business use case attached. So we all know that as a country, we are a very young population, right? We know that a lot of our population is towards a younger age. So we are a very, very young country, right? But similarly, countries like Japan, their average age is very high. So the population is an older population. How do you represent that data in a chart so that someone can visualize and understand that there is a distribution difference in the age of citizens of the two countries, right? So let me take just one color. I'll pick one color. and this color will be our Indian representation. So you can see the India's age distribution will look something like this. We have a very younger population, and it would go somewhat like this, right? And what this is for us, guys, we need to know this is basically the age axis. Okay, this is the age axis. Now, if you look at Japan, their distribution will be a little different. Their distribution would somewhat look reverse of what India's is. It will look somewhat like this, right? These peaks actually represent the average age. So this actually is going to represent the average age of Indians. So it's a smaller value on the age axis. And this represents the average age of the Japanese, of Japan as a country. And they have a higher average age, right? So this particular chart, which is the distribution chart, gives us an idea of the distribution, first of all, being either equal, right? Equivalent distributions. No, you can see India and Japan have a significantly different distribution. And they also tell us the difference between the average values of the distributions. Clear, everyone? Right? The next type of analysis is the relationship analysis. So relationship analysis is very important because it gives you a very important understanding of the relationship between two variables or more than two variables in certain cases. Okay, let me show you an example. I'm trying to draw it out so that you guys can visualize what I mean when I say I can do a comparison or not. Okay, so suppose we had, let's say, the y-axis. I have the y-axis, which is the sales. The y-axis is my sales axis. What is the sales of my company? And I have the x-axis, which is marketing spends. This is the amount of money my company is investing in marketing. Okay. Now we obviously know that the more marketing we do, the more sales we are going to get. Okay. The more marketing we do, the more sales we are going to get. So what would it actually look like in question? Suppose I collect data. Okay. I actually collect data, which is somewhat like this, right? This is my, let's say, 2 data points. I have 2 columns of data. One is my marketing and one is my marketing spends and the other is my revenue. So let's say this is my marketing spends and this is my sales. Okay. Now I have different values here and there. Okay. I have some value for this, 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 and I have a lot of data points. These data points will actually transform into different points on this 2-dimensional axis. Right? And it would look something like this. When you look at this kind of a scatter plot, what is a scatter? A scatter is a point on the 2-dimensional plane where if I try to plot one on the x-axis, this will represent my marketing spends, and the corresponding y-axis value, which is sales, will represent the sales. So this is actually a point which acts as a row in this data, right? Now what I see is I can actually clearly understand that there is a clear trend. What is that trend? That trend can be represented by a straight line. There is a clear trend that if I increase my marketing spends, where I go more towards the x-axis, my y-axis also increases, right? So I can claim the relationship between marketing spends and sales is a positive impact relationship. The more you invest in marketing spends, the more sales you are going to get, right? Similarly, we can also have other relationships. What are these other relationships? I can have a negative relationship as well, where the curve would look something like this. The points that I have will look something like this. Right? This signifies a negative or an inverse relationship. What do we mean by that? The more I move towards the x-axis, when I increase one thing, the other thing decreases. Right? This decrement specifies that if you do more of something, the less of that. For example, if you eat more food, your health deteriorates. If you eat more junk food, your health deteriorates, right? If you smoke a lot, your health deteriorates. So, I mean, it has an inverse relationship. Yeah. Okay. I see a question from Nisha. In distribution, it's only histogram. This one you're saying. So column chart is also a type of a chart. Line histograms are also. So if you just like, let's just go quickly online. Column distribution histogram. Column distribution, that's simple. Right? So you can see this is one distribution like a histogram. If you look at a histogram, what they do is that they convert this into a curve also sometimes. So you can change the bucket sizes, right? And finally, we had another one, which was line histogram. So you can actually go for line histogram also. Right? So here they have actually done a histogram and then they've actually added a line that estimates the histogram. Okay. So, I mean, these are like largely histogram is used for distribution, not the other ones. Okay. I hope that makes your question answer clear, Nisha. So relationship as scatter chart and bubble chart. Bubble chart is a little different than scatter chart because in a bubble chart, rather than a two-dimensional plane, you can actually represent a three-dimensional analysis also. Let me show you an example. Suppose this is my current chart. Okay. Instead of my points being each of same size, right? This is the same size points, right? I can also have varied size points like this. I'll tell you what this means. If you see, with a smaller value of x and a smaller value of y, I am also getting a smaller value of this third dimension. The smaller value basically represents, in a way, would represent your third dimension. So in this particular case, it would be something like, suppose you have 3 columns, right? You have column 1, column 2, and column 3, right? In this particular case, one column of yours could be just like it was before, the marketing spends. The next column could be your sales, and finally it could be profit. Okay, so this gives us a very good understanding that when we increase our when we increase our marketing spends, our sales increases, and so does our profit. Clear, everyone? Guys online, right? So the marketing spends, again, let's say, is an x-axis. Sales is on the y-axis. and the profit is the radius or the size of this circle. So smaller marketing spends, smaller revenue, smaller sales will give you low profit. Higher marketing spends with higher sales will give you more profit. So you can also imagine that with a higher marketing spends and a higher sales, your profit will be low. But with a lower marketing spends and a higher sale, your profit will be high. So this curve will actually be somewhat like this. And that represents the relationship of spends, sales, and profit. Clear? Guys online, everyone, yes, no? Now, coming to composition, we have pie chart, stacked bar chart, area chart. So what does a pie chart? I mean, all of us know what a pie chart is. And what a pie chart really represents is the composition of the different categories in the totality of the data. So let's say that I have 100 customers. I have 100 customers. Okay. In that 100, 20% of my customers are in the age group of 12 to 25. The remaining 30% are in the age group 25 to 40. And the remaining 50% are in the age group 40 to 60. Right? So 100% of my data is actually covered by these three categories. And how can I represent that? I can simply draw a straight line here. This entirely will be my 50 to 60. I mean 40 to 60. Because it covers 50% of my data. Right? And then this will be split into 20 and 30%, the remaining 50%. And that would somewhat look like this, let's say. Let me undo this. I have to go from the center. Somewhat like this. Is that clear, everyone? This will be 12 to 25 age group. Right? And this will be 25 to 40. Clear, guys, everyone? Yeah. So pie charts help me do a composition analysis. How much of a particular category is occupied in totality with respect to other data points, right? So I can actually look like, let's say, out of the accounts that I have, out of all the accounts that my bank has, how many accounts are business accounts, corporate accounts, savings accounts, FD accounts, right? So this can tell me if my branch or if my bank is doing great with respect to the type of accounts I want. Suppose I want more of fixed deposit accounts and less of zero balance accounts. So I can create a pie chart where each pie will represent the percentage in total of the account type. And then I will be able to justify that, from the previous month and this comparative month, my number of fixed deposit accounts have increased. So I have performed really well. Okay. Clear, everyone? Just let me know if you have any questions. You can compare more data in pie chart together. Yes, Nisha, that is true. You can compare more data in pie chart. Those are a little more complicated pie charts. Right? So you can actually have pie charts of very different kinds. Okay. If you go for a little complex pie chart, right, you can see that it can go like this also. So there is categorization of pie chart. In the total text mining business, there is data mining techniques, data mining tools, knowledge discovery, process, data mining applications, patterns. Inside patterns, there is databases, techniques, extracting, application, business, etc. Inside databases, there are multiple subcategories. So pie charts can be made very, very complicated. This is also an interesting example. You can see that this is the pie chart of a project management team. There is MM, CO, PM, QM, all of these. Individually in these roles, they have multiple players, multiple employees. Okay. Coming to the Next, this the entire process that I want all of you to think about. For each chart type, you need to, for each analysis, you need to define the analysis type, and based on the analysis type, you have to define the chart that you are going to use. Okay. Then what you need to make sure is, how can I add maximum information in the chart so that my viewer, my customer gets all the facts directly by looking at the chart. Once they look at the chart, they should not have any, I would say, misconception or any particular assumption or estimation that they have to make. For example, if you look at this particular pie chart, if the numbers, the percentage were not there, it would have been a very confusing, or I would say ambiguous chart, right? Because when I compare wedges or pies that are close to each other, then I can compare. But if this is a big chart and there are these two wedges which are very separate from each other, I cannot actually compare visually which one is greater than the other one. The numbers help me actually understand which one is greater than the other one. Does that make sense to all of you? Yeah. So if you look at a pie chart, there are lots of pie charts. But if you look at this pie chart, just look at this pie chart without these top legends. Just ignore these legends. Let's say we just know this part of the pie chart. So this is very confusing because I have no information about what blue means, what purple means, what yellow means, right? Let's say I know what blue means, purple means, and yellow means, but I don't know the percentages that blue covers, purple covers, and yellow covers, right? So I always have to define a chart which has all the information, specifics, which are numbers, and have a clear communication to the user. Okay. And that's how charts should be made of. Okay. So define the chart type based on the analysis type. Define all the interesting aspects of the chart that you want to display to your user. For example, if you look at this chart, there are very important highlights that you should consider. The first one is you should have X label, Y label. This tells the viewer, the customer, what does the Y label represent? What does the X label or X axis represent? In a bar chart, you need to specify the categories or the values that correspond to the height of each bar, right? You should also be able to give the topic, the chart's name, right? What does this chart represent? So this is the entire idea behind the chart. What does this chart show, right? You should make sure that it shows the numbers so that if the user wants to manually calculate some height, they should be able to using the grid and the height of the bar, right? All of these individual but very small and minor complexities that you keep adding to your chart really help develop a good connection between the viewer, the chart, the person who looks at the chart, and the person who has built the chart. So look at this. This is a very interesting chart. Why? Because it adds a lot of detail that I want to look at. You can see that it shows the chart style, this is the chart style. You have to find the detail of the chart. The image title, very important. Okay, what is the title of the image? This tells us what the chart is showing. Labels. So this is the y-axis label. The x-axis label should have also been given. These are the values of the x-axis, but there should also have been an x-axis. Okay, so this is missing, right? Legends, which is what colors represent what ideas. So the blue represents men and the orange represents women. This is clearly indicated by the legends. Okay. X and Y titles are what we talked about. Scales on the X and Y axis. So this scale is very important. If I want to know the absolute value, I should know the scale. Okay. Proper choice of colors. So you can see both of these colors have a good contrast between them. So I can clearly separate the two colors, right? As well as none of these colors are too bright for me. They're very visually easy on my eyes. Color intensity. So if the orange is a very deep orange and the blue is a very light blue, does not make sense. So both the colors should have a good amount of intensity, which are comparable to each other. And finally, figure size and quality. If you can view the image clearly, if the boundaries of the bar chart are clearly visible to you, if it looks like an HD quality image, that's when you can be sure of the figure size and quality. Okay, let me also give you another example. Suppose one of your charts that you have built has a lot of categories in the x-axis. One of the charts that you have built has a lot of categories in the x-axis. When it does have a lot of categories in the x-axis, I would ideally want my chart to have a dimension like this. Sorry, let me undo. I would like my chart to have a dimension like this. Why a dimension like this? So that in my x-axis, the values are clearly separate from each other. I want a good amount of gap between all the bars in my x-axis. Right? Suppose I have 10 bars to show on my chart. I really want all my bars to be very separated, clearly indicating the trend, right? On the other hand, if it is a smaller x-axis, then I will have to fit everything in a very small space, right? It will be a very close fit. Once that close fit comes, the other problem would also be that I have to give names to all of these, and those names will get merged together, which I don't want. Okay. So you have to also define the figure size and figure quality to suit the needs and proper clarity. Yes, Nisha, scaling is important. That is correct. Right. In most of the charting libraries or visualization tools, the scaling happens automatically. So we usually don't have to worry about it, but sometimes we need to. Okay. Now, instead of just these basic charts and visualizations, we also have something very, very specific and something very interesting that a lot of stakeholders want to know. I would say peers, engineers, colleagues want to know. Suppose if someone asks the technical head of everything at Facebook or Microsoft or Google or Netflix, they actually have to show what is the architecture of their platform. What is the design of their technology? Suppose if I go for Netflix system architecture, if you look at that, you can see that it's a very, very complicated, highly fast, optimally efficient architecture. So you see, Netflix can be accessed via multiple platforms. So this is what they show. You have a laptop, a desktop, a computer, phone, PS, whatever. Using that, you can access it. This is accessed by an internet connection. The internet connection is served by the NetEase server. The NetEase server gets response from all of these individual backend servers. It is connected to multiple technological platforms where there are cache services, microservices, what databases they are using. So you can see AWS S3 is used. What is the searching tools that they are using? What is the performance optimization, event collection? What is the queue? What is the transcoders? This entire diagram or chart actually, I mean, obviously not to people like us who are not software developers, but people who are software developers, they will get to know what is the design architecture of how Netflix is able to provide top quality video streaming to the world, right? And that is where diagrams like these are also very important. Okay. This will help you try to in a way structure the ER diagrams. What are ER diagrams? ER diagrams are basically entity relationship diagrams. In a SQL server, it's disjoint and disjoint bar graph, joint bar graph. Yeah, Nisha, that's correct. You usually want disjoint bar graphs, okay, when you're trying to compare. Now, so these can help you build right ER diagrams, right? ER diagrams are basically how databases are connected to each other. Suppose if you are working for a platform like Flipkart, so you will have your transactions database, orders database, customer database, product database, and all of these are interconnected. one customer has bought multiple products. Those products will be in the product database, right? This particular customer actually has has been buying a lot of things in the past also, right? This customer has a particular kind of choices. So he buys a lot of mobile phones or he buys a lot of books, etc., etc., right? So all of these databases are interlinked, connected to each other, and that can be represented by ER diagrams. So if you want to look at what ER diagrams look like, you can just quickly do a Google search, right? ER diagrams look something like this, right? There are different entities. There are student, there is course. Student has student name, student age, student ID. Course has course ID, course name, right? And student is going to study course. So these are relationships between the different entities, and they can be very complicated for a larger database. They can be a very simple one for a smaller database. Okay, so these diagrams are also very essential for software development. State flow relationships. Now, what are state flow relationships? They tell us about how data moves through the platform. Suppose Facebook state flow diagram would be user uploads post. Post gets stored in the database. From the database, a notification is generated that renders the user's data on the Facebook page. This notification goes to everyone. So the entire flow of information, starting from the user interaction to the end user, I mean, your friends and family members are able to see your post, that defines your state flow. System design, like we talked about, input-output relationships, individual or grouped behaviors, additional special behavior of objects, system performance bottleneck. Suppose the bottleneck is a very important example because this has helped a lot of software developers build really great quality code. Okay. Suppose the situation arises where you have multiple things that are accessing your product or your platform. If all of those things individually access a particular resource, let's say all of these are accessing an image or a website or let's say a data point or let's say a video or whatever, and this particular entity is getting affected, right? You know that this diagram shows and clearly represents that this particular box is a bottleneck, right? This bottleneck actually explains to you that if this fails, your entire system may crash. So what we'd really be trying to do is we are going to create copies of this. Okay, we are going to create multiple copies of this. We are going to make sure that a certain set of systems only access, let's say, the left one. We can say these are going to just access this, right? These two are going to access this, and the last one is going to access this, right? Also, because this was originally a single one, we will also define the relationships between them by saying that these two are connected as well as these two are connected. So all three of these are going to be interlinked and connected. So this kind of diagram really helps you understand the bottleneck of your systems and where your systems might fail, right? Multiprocessing architecture also gives you a similar idea. Other than these very common or popular visualizations, there are also some interesting visualizations that are not very common, and they are used for specific applications. Okay. Any questions so far? Yes, Nisha, distribution of resources. That's correct. Any questions, guys? Let me take a few questions. Okay, do let me know if you have any questions. I don't see any on the chat, so I'll just continue. The first chart that you see here is a geospatial visualization. What is geospatial visualization? It actually gives you an analysis geographically. So suppose this is a particular state or a city, right? This chart actually can tell me a lot of, let's say, if you want to know the market penetration. So if a lot of your customers reside in a particular area, let's say you call that place to have a lot of market penetration, right? So let's say this is my market. This is where I do my service. In this service, the color represents the intensity of the spread of my customers. Suppose if my customers, like you can see this red area, right? This means that I have a lot of customers here, right? But in the center, I don't have customers because they are mostly yellow, right? So yellow represents low market penetration, red represents high market penetration. When a user, when a businessman or a stakeholder or the CEO looks at this chart, they understand that we have been able to penetrate the market in the outskirts of the state or the city. Now we need to kind of target the people living in the center because there's a lot of business scope, business opportunity available towards the center of the city. So when I do my marketing, I will do towards the center of the city. When I have my billboards or, advertisements getting displayed, they will be on the center of the city. When I try to contact customers, I will try to contact from who live in the center of the city so that I can expand my market to the center, just like I have captured the market towards the ends or the outskirts of the entire state, right? So this gives us opportunity to analyze the data at a geographical level. So what is the geographical affluence? In which area in the state are people more rich, right? Where can I sell luxury products, right? So suppose if let's say a big brand like Levi's wants to open a new store, will they open it in a place which is close to, let's say, a very poor region, right? Let's say Chawls, right? We all know about Mumbai Chawls, where, a lot of people live in a very small area, right? They are like small huts. So will Levi's open a store there? No, because Levi's knows that the people who are going to afford these Levi's jeans are not living in that area mostly, right? I'm just trying to, I don't want to be discriminative, but that's the way people find out, like, this is where I want to place my store. For example, you will never see a truck tire repair puncture shop in the center of the city. They're usually in the highways because these guys know that trucks are going to pass through the outskirts of the city, through the highways. And that's where the trucks might get punctured and want to be repaired. You will never see a mall and beside a mall see a truck puncture repair shop, right? That's because the area, the geography plays a very crucial role in defining the business potential of the particular product, company, or service. Okay. The next chart that you see is a very complicated chart. Sometimes it represents a tree map. Sometimes it's called a composition chart, which is a little different than the actual composition. So remember, we were looking at a pie chart which had different categories, right? So largely there was one category, then towards the end there was subcategory, and again there was subcategory. This is a simpler chart to represent that. This says that there are two kinds of majors: Bachelor of Sciences, Bachelors of Arts. In Bachelors of Sciences, there are 4 majors: math, physics, biology, engineering. In Bachelor of Arts, there is English, history, music, and philosophy, right? So this is a hierarchical chart or a plot to represent composition of the data. Okay. Now, this is called a heat map. A heat map actually represents by color the relationship of one variable with the other, right? So we were talking about the positive and negative relationship. Now you can very easily understand the same with a heat map. You can see plus 0.8 represents a very high positive relationship. Minus 0.8 represents a very high negative relationship. What that means is if one thing increases here, the other also increases. Here, if one thing increases, the other decreases. Okay. And in the center, there is no relationship. That's basically like a straight line plot where changing one does not impact the other. There is no change in y-axis when there is a change in the x-axis. Okay, so these colors represent the intensity of relationship, and these highlight very important relationships. For example, I know that these are very highly green. So I know that these two columns and this particular column are highly positively correlated to each other. They have a very strong positive relationship, right? So the heat map helps me understand the relationship between different variables. Then comes the time series plot. Okay, the time series plot is also very interesting because any time series, if you look at any particular time series, it can actually be decomposed into 4 different parts. Okay, what are these 4 different parts? Suppose this is the actual time series. Okay, suppose this is the actual time series. In this time series, there is a trend which you can see here. There is a trend. Trend means the larger upward or downward movement of the data. Then there is something called as cyclicity, the periodic ups and downs faced by the effect of time. For example, if you want to plot the sales of mangoes in India, you know that in the summer season, the sales of mangoes increases. In the winter season, the mango sales is almost zero. So it is because there is a seasonality of summer, winter, summer, winter, summer, winter, like that for the sales of mango. So there is a cyclical effect. And then there is error or randomness. So one year the produce was very good, so the mango sales went high. Other year the produce was not very good, so mango sales went low. These are things that are not dependent on the industry or the time period. These are just random factors that no one can control and cannot be predicted. This is the margin of error that we should accept while making a prediction. Okay, so it's called randomized error. Okay. Choosing colors efficiently, always understand that bright colors are not a very pleasing sight to view. So whenever you see that a lot of bright colors have come up, don't use it. This is not this is very hurtful to the eyes. Okay. Then colors should actually represent idea. For example, in the stock market charts, you can see negative represents that there was a downfall. Green represents that there was an upward trend. So if higher sales were made, if the price increased, it was green. And if the price decreased, it was red, which you can see with the color. So color is very essential to represent the idea. If there is no idea, that's fine. But if there is a clear-cut idea, always use colors to represent those ideas. Okay. Use the color differential. For example, cool colors are one where the analysis is not very intense. So if you want to do an analysis that is very critical to the company, use I would say very important colors. Important in the sense like colors which are like red, white. They have a lot of contrast, blue, right? Colors like those. And if you have a very simple analysis, you know, distribution of this by this, relationship of this by this, then you can use a little more warm colors, right? Yellow, green, light blue, things like that. Or each colors have its, you know, interpretation also. So royalty, serenity, wellness, positivity, youthful, passion. So, I mean, there's some things that a lot of people suggest. You can choose to use them or not. Okay. So there should be contrast. There should be a very clear differentiation. Don't go with the bright colors. Choose from the basic ones. The basic ones are always good to go. Understand color psychology and represent colors with the right color size. Okay. I mean, with the right color. Right. For ROI and detailing cost, you should always be looking at composition charts like pie charts. You should be comparing stacked bar charts over the time period. So you can see if your business is growing, not growing, stagnant, which particular part of your business is actually making a lot more growth. For example, your profits are growing, but your sales and revenue is not. What does that mean? Your cost could be less. That's a possibility. Or let's say your sales are growing, but your profit is not growing. So what does that mean? That cost is increasing by the same amount. So you should have the ability to look at cost individually over the years, revenue individually over the years, and profitability individually over the years. So you can see how these three are moving over the time period as well as with respect to each other, right? So detailing an ROI, you should always look at composition and time-based relationship charts. Okay, comparison charts, right? You can also look at these bottleneck special charts. So what they mean is, let's say I started with $48,572. Then I gave my employees their salary. So I was left with 32,483. Then I gave my infrastructure cost, electricity cost, internet cost, etc., etc., etc. Right? Then I got some value. Then I got some value. And slowly and steadily, you can see that the bottleneck is achieved. So starting from a large pool, small subtractions, in the end, you reach your final profit. So that's also a good way to represent ROI. Number representation with stacked and line chart, that's also a great one. The composition and percentage coming from each of the individual marketing channels, that also helps you compare your ROI. For example, in this case, you can see that email marketing, right? Email marketing is giving me less ROI than content marketing. Paid search is giving me more ROI than affiliate, right? So I will know which ones are performing well and where should I add more and more money, or where should I remove money from. I should also compare the spend and the ROI, which you see here. You see a very small spend and a very high return represent that it's a great channel. High spend, high return is obviously going to happen. And high spend, low return is the worst case scenario. The best is low spend, high return, right? Finally, you should also look at dynamic visualizations. By dynamic, I mean, when you look at something, you can just point, highlight it, and you get more details about it, right? For example, dynamic charts could be have more information about each and every aspect. It can give you a lot of critical information that cannot be incorporated in a single chart, right? I mean, let's say you have 10 data points about a single plot on the screen. So you cannot show all 10 data points, but if you highlight that point, or if you click on that point, or if you keep your mouse over that point, you should be able to get that 10 extra information also, right? It adds a lot of cosmetic value. Cosmetic means it looks better. It feels more reliable. Customers think that this is a live active platform to do, right? And you should understand that there are different levels. So for example, if you're looking at a geographical plot, you can look it at the country level. Then you might want to zoom in and look at a state level. Then you might want to zoom in and look at a city level. So in that case, a static chart will not help you. A dynamic responsive chart is very essential. Okay. It adds a lot of extrinsic value, geographic analysis, like we said. This is a must for large data set, because in a large data set, you cannot plot everything on the screen. So you have to make sure that they are either plotted by parts or they have a hierarchy, right? So you can actually go down the hierarchy one by one and do the analysis. Okay. And for softwares like Excel, Power BI, it's very easy. For Python developers or ones who want to program it, you should use Kepler GL or Plotly. Plotly is a Python library, and Kepler GL is an open source library developed by Google developed by Uber for geographical analysis, right? So I think that was it for today's webinar. We discussed a lot of content, lot of interesting ideas. We discussed on how to proceed, how to think about plotting, visualization, charting. If you guys have any questions, I will wait. The last 5 minutes are for Q&A. And once, if you have any questions, I'll definitely want to answer them. And post that, we'll end the webinar. If anyone has any questions. Okay, then great. Yeah. Thank you for your time, everyone. I hope you guys had a lot of fun learning about the visualization for business intelligence. I had a lot of fun explaining all the concepts and things that I've learned over the last few years. And I hope to see you soon in another webinar. Have a good day. Thank you. Good night.